Hello friends, welcome again, and today we are going to solve a new question, and this question is also from linked list part, and the question title is rotate linked list. So in this question we have to rotate the linked list, and there is a value k which gives us how many times you have to rotate it. So in example you can see that this is a given linked list, and it has been said that we have to rotate it two times. So here in the image you can simply see that what is the rotation means. So it simply means that you have to move all the elements or all the values present in these nodes in forward direction one time such that it will move in a circular loop. So if you assume that this head and tail are connected, then you have to move it in a circular order, that means in right side. So all the elements present in this linked list will shift one times to the right side. So how many the value given with the but what is the value of k gives us that how many times we have to shift these values. So here it is 2. That means we have to shift all these values in the right side direction in a circular way such that the tail and head are connected two times. So in the first rotation, you will get this type of scenario where on the head part we have 5, then 1, 2, 3, 4. And one again when you shift to the right part, what happens is that the 4 comes to the head position. So this is the overall working in this question. Now let's understand how we can solve this. So here I've taken the example one, which is given in the question and which we have already discussed. And here is the rotation one and here is the rotation two. In the rotation one and rotation two, you can see that it is moving in circular order. So first thing is clear to us that this node, which is the tail in the initial linked list and the head in the initial linked list, are going to be connected in order to move the nodes. So what we have to do is that we have to reach at the end of the list and we have to connect this tail to our head. So this is going to be our first priority. That means it is always going to occur. That means we have to do in each and every situation, we have to connect our tail and head. Now we have connected this. Now this is a circular loop. And now what we have k. And what is k? K is how many times the nodes are going to shift. So here you can see if k equals to 2 as given in this question, what is happening is that your 1 is now shifted to 2 position ahead. Here you can see it is at this position. Similarly, 2 will move to position ahead 3, 4 and 5. So this is what happening in this question. So what we have to finally do is that we have to return the head. So we do not need to consider any situation or any we do not have to take care of any other thing. Only thing which we have to do is that you have to find the head and we have to return that. So here you can see that if the k is 2, then what will happen? That your head will change. But which node is going to be our head? So the node which is just 2 position before the tail, initial tail, is going to be our head. So here you can see that the 4 is at the second position from the last. So this is going to be our next head because it's moved two times. So in the first iteration it will be at the tail, and in the next iteration it will come at the head. So the node which is at the kth position from the end is going to be our head. So this is an important situation, important case by which we are able to get the head of the linked list. And after you get this head, one thing we have to also take in consideration that the node which is just previous to it, that means in here it is going to be 3, must point to null. That means 3 next must point to null. So if we simply get the 4 and we are able to point the previous to the head to the null, and then we can simply return the head because we have already connected it. So if we now return it, if you point this 3 to null, what will happen? You will get a new linked list, which is this linked list where 3 is pointing to null and your 4 is going to be our head. So this is a simple question, and I assume you have already understood what we are going to do. So I have distributed this in multiple of steps. First is going to be we have to connect our tail to head. Second, what we have to do is that we have to find where our head lies. So how you are going to do is that I have already told you it will be the second kth position from the end. So this is our second. We have to find our head, and when we are able to find our head, then simply what we have to do is that we have to point the one node previous to our head to null. So third step is point the tail to null. That means new tail to null. Here we have to point 3 to null. And in the fourth step, what we can do, we can simply return our head, which we have achieved in third step. So this is the four steps process by which we can simply solve this question. Now let's code it. So let's start by taking some conditions where we can simply return the head. So you can check that if your head is null. So if your head is null or your head next is null, that means if your head is null or you have only one node, that then it is not then we do not have to do anything. We can simply return head. One condition also, if your k equals to 0. So if your k equals to 0, then also you can simply return head because it doesn't matter of rotation. So we have to return head. Now here we have to start our main code. So what we are going to do is that we are going to initialize a pointer temp, and this is pointing to our head. Another pointer which we have to take is h point star h, which is going to be our final head. You can also point it to initial head, or you can just leave it. Now after this, we are also declaring a length, which is going to be our length of the linked list. And why we are taking that? Because we know that the new head lies at the kth position from the end. But in order to find this, we need to find the position from the start. So for that, we need the length of the linked list. Now, for the first step, that means in order to point your tail to head, we need to iterate through the linked list and reach at the tail. For that, we are running a while loop while our temp next is valid, that means not null. We are doing temp equals to temp next. And after this, we are also increasing our length. So this is the complete loop, and after this we have reached at the tail. So first we have to do is that we have to write temp next equals to head. Now after this the first step is complete. Now on the second step we need to find the position of the head from the start. For that, one thing which we have to first do is that we have to update our k. So we are going to take a variable capital K is equals to. So here you can see that your k can be a very large value. That means it can be greater than the length of the linked list. So if your linked list length and the k equals are same, let's see in the example one. If your length is 5 and your k is also 5, that means every node is going to rotate it 5 times. That is finally it will be equivalent to zero rotation. So for that we are going to take k mod k mod L. Now after this, in order to find the position from the start, we are going to take a variable j and we are writing L minus capital K. So it is going to give us the position from the start. So finally, we have to go to the position where our head lies. So we are going to run a for loop. For int I equals to 0, I less than j, I plus plus. And this we are going to write temp equals to temp next. So here you can see what we are doing is that let's assume here in the example that we have k equals to 2 and length equals to 5. So what is the value of j? J is going to be 3. So how many times this for loop is going to run? This for loop is going to run for I equals to 0, 1 and 2. That means 3 times. Your temp is lying at end of the linked list, which is the our initial tail. Now when you run the for loop one time, your temp will go at the first position, and when you move I equals to 1, it will go at 2. In the third iteration, it will arrive at 3. So this is the node which is just previous to our head. So this is going to be our new tail. So finally your temp is at the position which is our new tail. So what we need to do is that we need to first store our head in a variable which we have here declared h. So we are writing h is equals to temp next. And after this, what we can do is that we can point our tail to null. So which is going to be next equals to null. So this is the complete. That means we have created a loop and we have find the head and tail and we have break the loop. So we have found our new linked list. So we can simply return h. Now let's run this code. So this is accepted. Now let's submit this. So this is accepted. So this is a question for today, and this is a simple question which you can simply do by logical thinking. Now you are going to see the solution for both Java and Python in the same video, and let's meet in the next video where we do new exciting questions from the linked list part. Now till then, keep learning and exploring. Thank you all.